Hello class, welcome to the next segment in the week 9 material. And in this segment we're going to start exploring something called the MatPlotLib module, which allows us to plot information onto graphs. And the first thing that we're going to cover is how to make sort of a line plot. And in the next segment we're going to actually cover how to make a contour plot, which gets a little bit more interesting, but for now let's just get some ground on how exactly the MatPlotLib module works and how we can actually plot information to a graph. So to start things off here, I've got a Python list here. So I've got a Python list which contain an assortment of temperatures that are in Celsius. And here I've got this other thing going on where I have hours equal to list range, which I'm going to come back to this a little bit later on. But just so that we know what values we're actually going to be working with, I just went ahead and introduce those. But one thing I'll also go ahead and mention, this is the entire module name that you have to import in order to actually plot information to graphs. And this kind of goes back to something I was saying earlier about the as keyword being such a helpful tool. Because you can see here how I'm referencing the matplotlib module several times here, and it would be very tedious and cumbersome to write that same module name out over and over and over again. So to make things really simple and to make things more efficient, we're going to take that module name and rename it to PLT. That way, wherever the computer sees PLT, it knows we're talking about this module that we just brought in, and that makes our lives much easier because trying to type this out over and over and over again would get very tiresome very fast. So this is I just want to reiterate the as keyword, and I really want to illustrate why we choose to use this sometimes and how it can be really helpful. So now let's actually get into what's going on here. So there is a function within the matplotlib module that is called plot, and that's a function that you would use to plot some sort of line on a nice Cartesian grid. So that'd be in terms of x coordinate and y coordinate. And the values that you give the plot function are kind of go as follows. The first value that you give the function is a list of x values that you want, a list of x values that you want plotted on the graph. And the second value that you give the plot function is a list of y values that you want plotted on the graph here. So basically what you end up doing is also this, I say list here, this can also be an array. You just have to make sure that there's something there that has multiple different entries in it. So again, this list will be holding on to some x values, and this list will be holding on to some y values. So in a way, these first two entries give the plot function a sequence of ordered pairs, and it just simply plots those points in the order that they appear in the lists. So in this case, it would first plot 25.4. And actually, let's go ahead and take a look at what is going on with this hour list here. As if I get that annoying error message every now and then. So if you take a look at this hour list, you can see how I have an assortment of numbers in here. So what all this does on line 5 here is this just creates a list of numbers starting at 0, going up to but not including 24, and counting up by 1 every time. So the range, you can also accomplish this using the numpy.arange function, which is something we looked at in the previous segment. But you can also use the standard range function to accomplish this. Since I'm working with integers, the range function is probably the way to go because it requires less memory to use. And I can also achieve the same result by putting a 1 in here. So again, much like the range function, start at this number, go up to but not including this number, counting it by this number every time. And you can see I do in fact get a nice list out of that, which contains a lot of numbers that are at evenly spaced intervals. So that's what's going on here with this variable hour. So again, this right here is hour, and this is the reason why I wanted to show this, is because I wanted to emphasize something very important, and that's something that causes a great deal of confusion semester after semester. When you go to put the plot function in here, the number of items in your list of x values must equal the number of items in your list of y values. If those two lists or arrays do not have a one-to-one correspondence, that is, they don't have the same number of values, you are going to get error messages and you might get really frustrated as a result. So make sure that the list that you put in here for x values has the same number of items as the list that you put in here for the y values. And I'll also go ahead, while we're talking about this, I'll go ahead and demonstrate a common mistake that I see semester after semester, which is something like this. Now, this list right here contains two values, 0 and 24. Compare this to what we had before, where we had 24 entries inside of this list here. Here we have a list that has only two entries. Those entries are 0 and 24. If you try to argue otherwise, I will say point to the entry on the screen here that is entry number 4. You can do that in this list. Entry number 4 would be this. Keeping in mind the computer starts counting at 0. Cannot do this with this list. And the reason why is because this is in fact a list that has two numbers. This does not have the same number of items as the list that we had previously. So if at any point you find the temptation to try and do something like this, you're going to violate this one-to-one correspondence principle, and you're going to potentially be very frustrated and very lost and confused as a result. So make sure that these two lists that you're plugging into the plot function, make sure they have the same number of entries in them. Otherwise, you're going to get this as a result. X and Y must have the same first dimension, but have shapes. An item that's, you have a list that's 2 items long and a list that's 24 items long, which violates that crucial one-to-one correspondence principle. So let's go ahead and put this back the way it was so that we no longer get that error message. Now, the third value that you put inside of the plot function will tell you, will basically determine the color of the line. And there are several different values that you can put in here. This lowercase r will draw a red line, but there's several other things that you can put in here. So you can also put in blue, green, red, cyan, magenta, yellow, black, white. Although I probably wouldn't be using this very much, because if you have a white background and you have a white line, you're probably not going to see the line very easily. And there's also some other things you can do to style the line. So R with 2 hyphens will make a dash line. There's some other stuff that you can sort of play around with in here, but a nice R with only the R will make a solid red line. And there's something else you can put in here which may or may not be fully necessary. Here I'm specifying the width of the line, and for professional presentation, probably the values you're going to put in here are 2 or 3, maybe a 1, maybe a 4 if you want some extra emphasis on a particular line on a particular graph. If you start putting in ludicrously high values like 10 or 20, your line is going to look less like a line and more like just a massive polygon of sorts. So usually a nice value to put in here is either 2 or 3, maybe a 4, maybe a 1 if you want a particularly strong emphasis on a particular feature on your graphics. So value of 2 or 3 here, probably what you want to be working with. And this other portion that I have here, where I have label equals this string right here, this is something that we'll actually come back to when we talk about the legend function, because that is going to be working in conjunction with this. Now, the other things that we can we can sort of explore here, all of this is pretty straightforward. So plt.xlem. Now, this is where you do actually put a list that has 2 entries in it. And what this does is this sets the bounds for your x-axis. And you can also do a similar thing for the y-axis. So if I wanted to set the y-axis to some bounds, say like 20 and 40, so this would be the lowest value on the y-axis, and this would be the highest value. Whereas on the x-axis, it's y here and x here. This would set the x-axis, so 0 is the minimum value on the x-axis and 23 is the highest value on the x-axis. Now, something I'll go ahead and mention about these functions: when you're first going to plot information, it'd be a good idea to leave this out completely, because if you're not careful here and you set your x limits and y bounds to something prematurely, there's a chance that you won't actually see any of the information that you'll be plotting, because it'll be plotted off of the graphic. It'll be plotted beyond the scale of what you've allowed. So I would recommend, when you're first plotting information, to leave these portions out until you have a really good idea of what exactly you're plotting. But if you really want to clean up the graphic and make it a little bit more presentable, then it would be customary to use something like this. The xlim and the ylim functions will allow you to really focus in on the graph and make it a little bit more presentable. If you leave those out, then the computer will take its best guess as to what the x and y axes should look like, but you can adjust those, and the way that you adjust those is the xlim and the ylim function. And if we want to, we can put a label on our x-axis, and that is a nice string here. And we can also put a label on our y-axis, so hence the functions x label and y label. And all of these are being referenced from the MatPlotLib module, hence the PLT here. Remember PLT, because we use the as keyword. Python really knows we're talking about MatPlotLib because of the PLT to the right of the as keyword. So this allows us to make a label for our y-axis. This makes a label for our x-axis. And if you want to give the entire graphic some sort of title, that simply uses the title function here. plt.title hourly observation data will be the title for this graphic. And now we actually get into the legend. And this is something that works in conjunction with the plot function. So when you're plotting a line and you give it a label, this label is a way that the computer is able to keep track of what line should be labeled what when you go to put a legend on the graphic here. And the legend function is what allows you to put the legend on the actual graphic. And here we're going to be putting in the bottom right hand corner of the actual graphic. But when it goes to draw the legend, it will take a look at all the labels that it was given. And in this case, we're having a nice red line here. So it will actually make a legend where it will draw sort of a little red line and put this string next to that red line so that you have a way of better illustrating what exactly each line really represents. And this will become more apparent once we actually see what this graphic looks like. And down here we have the savefig function, which allows us to take our graphic as it is at this point in the program. So whatever our graphic looks like on line 13, it will take that graphic and save it to a file called this. So in this case, I have it called example9a.png. And this image file will be saved to the same folder that your Python program is in. So this kind of goes back to what we were talking about in the week 7 material, how if you're working with external files, you want to make sure the Python file and the external file are both in the same folder. And sort of the same thing comes into play here. Wherever your Python file is, that's where this image file is going to be saved. So make sure you know where this Python file is. Otherwise, you're going to be led on a wild goose chase trying to find where this file is on your computer if you don't know where your Python file is. And then finally, this CLF function. Basically what this does is this tells Python that we are done putting information on this graphic. Anything that appears after that will be on a completely separate graphic. So this basically enables us to plot or make multiple different plots in the same Python file if we so desire. And this is a way we can sort of put a separator in there so that Python knows all this should go on one graphic and anything that appears after this, that is anything that appears after the CLF function, should go on a completely separate graphic. But if we want to, we can go ahead and run this function or run this program to see what it does. And you can see it was giving me the sort of the same output that I had before. But if we go here and find, we do in fact have an image file in the same folder as our Python file. And you can see we got a nice, pretty graphic here. And here you can see this is the line that ended up drawing. So again, this is basically what we put in a list of x values and a list of y values, and it turns out when we connect all those ordered pairs in the sequence they were given, this is the line that we get. And there you can see it put the legend in the bottom right hand corner of the graph here. And then here's the title corresponding to what we have here, that string that we put there, and then the y label and the x label that we specified for our graph. And notice how this specific string matches up with this specific string. So that's sort of a first look at the MatPlotLib function, just simply plotting a nice line to a nice simple graphic. It turns out there is a ton of stuff that you can do with this module, with the MatPlotLib module. In fact, you could probably spend an entire semester or two just exploring what this module has to offer. I'll put a link in the description below that has basically as comprehensive of a reference as you could ask for the MatPlotLib module if you're really interested in exploring it further. There's one other thing that we're going to talk about, which is the ability to contour stuff on a graph, and that's something we'll talk about in the next segment. But I just wanted to sort of end on that note. The MatPlotLib module, there's a ton of stuff you can do with it. We won't be able to cover every single thing in this class, but if you get a good understanding of how exactly to set stuff up in a Python program using this module, then the sky's pretty much the limit. But that's going to do it for this segment, and in the next segment, we're going to take a look at how we can produce a contour plot, again using the MatPlotLib module. So with that, I will see you all there.